Hey, good morning, guys. What I wanted to do today is actually, let me start out properly. Namaste. All right. Hey, what I want to do today is go over the last part of astronomy, which is about the solar system. Now, up until now, we've learned about stars and galaxies and things like that, and now we're going to look a little bit about the planets. All right. So, if you take a look, and we'll start off. All right. With 20 chapter 25 part 1. Okay, and this is on the solar system. And all right, so go through it. It starts, here's the story. It starts, these are our ancestors, and um, tens of thousands of years ago, actually not even tens of thousands of years ago, but up until, actually, for the most part, as long as we were either living out in the forest or living out on the savannas and hunting and gathering, or even when we were in agrarian society, the stars were really important to us. Today, we don't notice these things as much. We're not an agrarian society, and the stars, looking up at the sky, is not as important to us as it was to our ancestors. They used the stars to tell time, to tell the seasons, to know when to plant, to know when to reap the crops, to know when the animals were going to migrate, to know when it was going to get colder outside, and when the spring was going to come back. So they use this. They use the sky and the stars in particular all the time. All right, because you could see certain constellations out in the sky at different times of the year. Okay, so it was much more important, and this is what they saw. They would see, a sky that we very seldom see today, because many of us live in towns and cities that are lit up at night, and you get what's called light pollution, which is great for walking around, on the ground at night. But if what it does is it kind of cancels out some of the light from the stars, and we don't see as many stars. Okay, even when we do look up. All right, this is a picture of the Milky Way. Okay, this bright band right here. We're looking at the Milky Way edge on, and where you see the dark spots like that. That is what you're seeing. Is you're seeing like nebula that are blocking some light, okay, from stars behind it. But this is actually, now remember, we're looking at a sideways view of the Milky Way because we are inside of it. All right, we don't have any picture of the Milky Way from above or below it. We know from mapping out stars in there with our telescopes and directions that they're going using their Doppler shifts or their red shift or blue shift. We know that the Milky Way is a spiral galaxy. Okay, but we can't see it. All right, because we're inside of it. All right, and every so often, when our ancestors look up in the sky, they would see these very bright stars, and there were five of them that you could see with the eye, and they did something weird. Okay, one, they were noticeable because they were bright. Okay, and two, they did something weird, and when you looked up in the sky night after night, they actually seemed to move. So you would see this star right here, and then the next day, the next night, you would look up and look at the same star, and it might be over here. So this star wouldn't move, but this bright star would. And then the next night, it would be over here, and then the next night over here and over here. So certain stars actually seemed to move, okay, and they were called wandering stars. All right, the Greek word for wanderer is planetos. And so there were five stars like this. So there were five planets, and they were named by various cultures. In our own Western culture, they were named after Greek gods or goddesses. So Mercury is one, Venus is another, Mars, the god of war, because it actually has a red color to it, Jupiter, and then Saturn. All right, and those are the five planets that can be seen with just the human eye. The other planets in the solar system, Uranus and Neptune, cannot be seen with the human eye alone. We need telescopes. In fact, they were discovered only after we were able to make telescopes. All right, so planets do this. Check out this next picture. All right. This is called retrograde motion. What this is a picture of the exact same point in the sky taken over a series of days. All right. So this is what we mean. And then all the pictures superimpose on each other. So what you're seeing back here, these stars are really true stars. What this is that looks like it's moving over time is a planet. Okay. And this is what our ancestors would see. Now, obviously, not a superimposed picture like this, but they would see it over, this effect over time. So here's one night, the next night it's over here, the next night it's over here, and so on and so on. Then it would do weird things. It would actually seem to change direction and move backwards, and then change direction and move forward again. All right. So it would make these really weird movements. By the way, write this down. This type of motion where the planet would seem to slow down, stop, and go back is called retrograde. Retro means back, okay, is in a retro rocket, a backfiring rocket, or just the term retro when we use it to talk about something that's from the past, okay? So this type of motion is retrograde, all right? Okay. Here's a little bit of history here. Write this guy's name down. His name is Ptolemy. He was a Roman astronomer. You have a rough time frame there. I don't make you memorize dates and things, but I want you to know roughly that this guy was 18 centuries ago, thereabouts. And he thought that the Earth was at the center and that all the objects, the sun and the stars and the planets moved around the Earth. And this is called a geocentric or Earth-centered theory. I also want you to know, don't go thinking this guy was stupid. He's not, he wasn't. He was a very highly intelligent man. People in the past weren't stupid, and you in today need to know that. They just didn't have the same information that we had, and they had to do a lot of things without the tools and the equipment that we have today. Ptolemy didn't even have a telescope. Okay, so he had to. So based on his observations, it does look like the sun is going around the Earth, and that Mars is going around it, and so on. And it doesn't feel like the Earth is moving. So based on his observations, this is actually not a bad theory. Okay, all right. So here's retrograde motion again. Here's a picture of it. Okay, this is the planet Mars from the month of May in the year 2008. Okay. Now, this is what Ptolemy thought was happening. When he would see this, he thought, and this is actually quite ingenious, he thought that the planets went around the Earth, but as they did, they looped like this. And he named these loops epicycles. Know that. Epicycle. Ptolemy thought that the planets, as they went around the Earth, moved in epicycles. Okay. All right. Okay. So moving on. Okay. But the Roman Empire fell. A lot of information was lost. I taught you guys the story of the Library of Alexandria. And then some 13 centuries after Ptolemy, this guy, an Italian working for the Spanish government named Columbus, was in one of these, and turns out he didn't fall off the Earth, okay? Because remember, they thought the Earth was flat for the longest time. And again, not a stupid idea. Doesn't look like the Earth is round because we're so small compared to it. Doesn't look like we're on a giant ball, all right? And he sailed around. This is a Portuguese caravel. All right, this was a state-of-the-art ship for the day, and he sailed it out into the Atlantic Ocean, and he bumped into a continent that he didn't even know was there. And the rest of that story. Okay, so now, interestingly enough, this guy Eratosthenes, all right, who lived before the birth of Christ, all right, 2 centuries or so before the birth of Jesus of Nazareth, all right, was a Greek who lived in Egypt, and he noticed he actually knew or calculated that the earth was round well before the birth of Christ. All right. This is one of those things, bits of information that was lost in history for a long time. All right. But he calculated it using shadows. He noticed that in the city of Syene or Syene, all right, on a certain day of the year, that the sun shone straight down at noon, wind up shining straight down a well, and the well didn't cast a shadow. And then on the same day, okay, in a different city, the city of Alexandria, which you guys know about, the sun did cast a shadow. It didn't shine straight down a well in Alexandria, but it did in this city. And the only explanation that he came up with was that the Earth's surface was curved. And he was actually able to do some 10th grade geometry and actually measure the circumference of the Earth. And he actually did it fairly accurately. Okay. Now, years after Ptolemy, again, around the same time of Columbus, is a Polish lawyer and amateur astronomer named Copernicus, who figured out that that the sun was at the center and that the Earth was just another planet and going around it. Now, this is kind of complicated. Here's why we get this retrograde motion. The Earth is going around the sun faster than, for example, this is Mars. So what winds up happening is, here's day one, and we look at Mars and we see Mars in the sky like over here. And then the Earth is moving. So is Mars, but Mars is moving slower. It's kind of like when you're on the highway and you approach a vehicle that's moving slower, so that's in a different lane. So the car is over here and you approach it, all right, and then you pass it. And then the Earth is doing that with the other planets. And then you see, so on the next day, the Earth is at a different position, so is Mars, and the Earth would, in straight line of sight, see Mars over here. Then the Earth eventually catches up with Mars and is right in line with Mars. And then the Earth starts to pass Mars, and that's where it looks like Mars starts to go backwards. And then as the Earth starts to continue around its circle, it actually looks as if Mars changes direction again, and so on, and then goes forward. And so that's where we get this retrograde motion. It's because that all the planets are going around in circles, but they're passing each other, and because they're going around in circles at different speeds. And we get this illusion that the planets are slowing down, stopping, turning around, then stopping, turning around again. Okay. Now, here's the solar system. Here are the parts to it. Obviously, the major part is the sun. Okay, 99.9% of everything in the solar system is just the sun. Okay, the first 4 planets are said to be terrestrial or Earth-like. Terra means Earth in Latin. Okay, planets, and these are Mercury, Venus, Earth, and Mars. Venus, by the way, is the brightest object in the sky. It's a planet. It's close to us. It's also almost the size of the Earth. Okay, so anyway, there you have it. These planets make up what are called the inner solar system. Okay, and then there's the planet Mars. Okay, and after planet Mars, there's a huge space until you get to Jupiter. And in that huge space are hundreds of thousands of these things. These are asteroids. They're material left over from the formation of the solar system that didn't form in the planets. And there are hundreds of thousands of these, and we will probably go there someday, because everything that we use on Earth, like metal and all the elements, cobalt, boron, things like that, same things that we find in the Earth crust are in the asteroid belt. Okay, and we can use these and mine these and make stuff out of these things, and we'll probably go there someday. I'd like to see it within your lifetime, and that could very well actually happen. Okay, and here's an example of, this is asteroid Eros. It's about 15, so some of these are quite big. It's about 15 miles wide, or 15 miles long. It's about 6 miles wide. Now, compared to a planet, that's really small, but it is a huge rock. All right, that has a lot of stuff in it. Okay, every once in a while, one of these things gets tugged out of orbit due to the motion of the planets Mars and Jupiter passing each other, and they fall into the inner solar system, and they wind up crossing our path. And when this happens millions and billions and millions of times, all right, any asteroid crossing our path, all right, for the most part, they're out there, but they're millions and millions of miles away from us. But when over the course of millions of years, a collision is inevitable. The last one was 65 million years ago, when literally this happened, when you have a chunk of rock the size of the island of Manhattan plowing into the planet at 200 to 300 miles every second. All right, it's a catastrophic event. Flashes the ocean into steam, and it will create the hugest tsunami you've ever seen. All right, not a 30-foot high one, but a 1,000-foot high one, and just reverberate throughout the planet, darkening the skies, and so on and so forth. Okay. All right. The next planets from Jupiter on to Neptune, these are called these are part of the outer solar system, and they're called gas giants. And interestingly enough, when you think of a planet, we think of something you could stand on. These are just huge balls of gas, all right, held together by gravity. Now, don't just because it's big, Jupiter is a big ball of gas, don't go thinking it doesn't have any mass to it. It's got a huge amount of mass. All right. The gravity created by the planet Jupiter is 2.5 times that of the gravity created by the planet Earth. All right. Why? Because there's just so much more stuff inside Jupiter. Okay. But you can't stand on Jupiter. If you tried to stand on Jupiter, you would fall and fall and fall and fall and fall until you just reach the center part, where you just stay. All right. And that's it. And you'd be underneath literally 10,000 or so miles, actually thousands, probably bigger than that, tens of thousands of miles of gas. Okay. Where it would be very, very dense and thick and gooey in there, and you'd never get out. The next planet is another gas giant, and that is Saturn. And Saturn is the one that has the rings around it. The rings are the result of a moon that got destroyed around Saturn for whatever reason or another. And it broke up into literally millions of pieces. And now all those little pieces orbit Saturn in the form of rings. Okay, Uranus, all right, is another gas giant, though not as big as Jupiter or Saturn, and the same thing with the planet Neptune. Okay, now let me go back on that. Oh, caca. All right, here we go. All right, the gas giants are not as you can't live on them, but interestingly enough, in terms of for human beings, they have many, many moons around them that can be mined or used or actually lived on and so on. So you can't live on these planets, but you could live on the moons, some of which are quite large, okay, and that revolve around these planets. Okay, here's Pluto. We used to consider it a planet, but here's why. All right, it's this is a view of an artist's conception of the planet Pluto and its moon Charon. Okay, there would be its moon, okay, called Charon. All right, and this is why, because so here's the Earth, here's our moon. This is Pluto and its moon Charon combined. Okay, they're really tiny. It's a really tiny, quote unquote, planet. All right, so it's not quite the same. Our planet has plate tectonics to it and stuff. Pluto doesn't have that. It's not like the Earth at all. It's just a solid big rock. Okay, is all it is. Here's Pluto and Charon. The two would fit in the United States. Okay, so they're really, really tiny. All right. Now, after Pluto and Charon, the last stop of anything that you could call the solar system is something called the Oort cloud. And if this is the sun in the center, these are millions and millions of huge chunks of ice, mainly water ice, okay, called comets. And that's what a comet is. A comet is not mainly rock. It's like dirty ice. And what I mean by dirty ice is kind of like when it snows and a few days later after it snows, how you get that ice mixed with sand in it that's off on the side of the roads, that kind of dirty ice that we find on the side of the roads. Okay, over time after after it snows, because initially when it snows, it's clean, but then after that, the snow gets dirty. That's what comets are like. Like there's these huge like chunks of ice. They're like maybe a few miles across, from less than a mile to a few miles across, of mainly water ice with other stuff in it like methane and little chunks of rock and stuff in it. Okay, that every once in a while, now unlike planets which travel in a plane, okay, around the sun. So the planets are all like in one line around the sun, one plane, if you will. The comets can revolve this way, they can revolve this way, they can revolve any direction. And they form kind of like this spherical area around the sun called the Oort cloud. Okay. Okay. Here is a picture of Comet Hale-Bopp. All right, named after Hale and Bopp, all right, two amateur astronomers who discovered it. And since there are millions of them out there, not all of them are known and mapped and charted. So you can discover your own comet if you are inclined to do that. All right, and some people do that. And when you discover it, you can name it after yourself. This one appeared over Rhode Island, actually over the planet Earth. In 1997, and this is a picture of it in the sky. All right, so there we have it. Okay, I'll let you guys do some questions to ruin your self-esteem and make you feel bad about yourself. Okay, and so on. All right, and okay, so hold on. Okay, so that's it for now. And here we go. All right, goal is out.